There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercurium, molybdenum, magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radon, xenon, zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard, and there may be many others, but they haven't been discovered.
Beneath Bolivia's surreal salt flats sits the largest deposit of lithium in the world. And now Chinese and Russian energy companies are getting ready to mine it. The lightweight metal is known as white gold because it's essential for making rechargeable batteries that power things like computers, mobile phones, and electric cars. Global production has nearly quadrupled over the last decade, but it's still not enough. So battery manufacturers around the world are eyeing up the lithium triangle, the name given to the high-altitude salt flats in Bolivia, Chile, and Argentina. This is where over half of the world's known supply of lithium is stored.
Tenemos la mejor salmuera con un alto porcentaje de litio.
The lithium here in Chile is locked away in underground saltwater, or brine. billions of gallons are pumped to the surface every year, where it is left to evaporate and concentrate. Mining companies also use millions of gallons of fresh water, and in one of the driest places on Earth, locals are scared of what that will do to their already scarce water supplies. And they worry they won't get their fair share of the white gold rush unfolding in their own backyard.
Que no nos estén incitando, porque nosotros también sabemos cuándo tenemos que levantarnos.
Mining the lithium triangle looks inevitable in the rush towards an all-electric future. But what is the true cost? Jose Morales has lived near Bolivia's salt flats his entire life. He makes a living growing quinoa and selling wool from his llamas. There is very little rainfall, and a nearby river that used to provide water is all but dried up. So Jose now pumps groundwater from wells.
Y año tras año sigue bajando el nivel. Antes aquí las familias convivían con el ganado sobre todo. Como había sequía, no había pasto, el agua se ha secado y han preferido migrar por fuentes de trabajo.
In early 2023, the Bolivian government granted a mining license here that would massively scale up lithium extraction. People like Jose are afraid that's just going to make the drought worse.
Estas plantas consumen buena cantidad de agua, y ¿de dónde va a venir esas aguas?
We'll come back to Bolivia, but for now, neighbouring Chile might hold some answers. These are the Atacama Salt Flats, a natural wonder, one of the driest places on Earth, and a vast source of lithium. The bright squares are pools of brine, where the water is left to evaporate and leave behind a mix of salts and minerals. The more yellow the pond, the higher the concentration.
Al principio veíamos color de turquesa, donde tenían poco porcentaje de litio. Acá ya tienen un gran porcentaje de litio, ya sea.
It can take more than 1,000 gallons of brine to produce enough lithium for just one electric car battery. Two companies control the right to operate here, American Albemarle and Chilean SQM. In 2021, Chile exported almost $1 billion worth of lithium carbonate, and satellite imagery shows just how that has transformed the landscape. It can take around 18 months for the brine to move through the series of ponds. The concentrated lithium brine is then processed into lithium carbonate, which is then taken to another factory near the coast where it is purified into battery-grade lithium. The two companies suck out enough brine to fill an Olympic swimming pool every 20 minutes. They also draw 32 gallons per second of fresh water from underground aquifers for use in the processing factories. That would fill an Olympic-sized pool in roughly 5 hours. It's no surprise that water usage is such a sensitive issue in one of the driest regions on Earth. Central Chile has experienced a mega drought since 2010, the region's longest on record. Brine is far denser than fresh water, and the two rarely mix, but regulators worry that pumping so much brine too fast will increase the risk of freshwater contamination. And lithium isn't the only thirsty industry here. Since the 1980s, copper mines have been responsible for around half of the region's freshwater use. The Chilean government blamed the copper and lithium industries for a 25-centimetre drop in the height of the water table. The copper mines plan to switch to desalinated water by 2030.